This series of videos is designed to help you master proofs in the congruent triangles unit, which is unit 5 at Edina. So, to begin, we are going to work on statements and reasons that you can use to conclude that sides are congruent. There are not that many reasons that you can use for side congruent statements. A side congruent statement looks like one line segment is congruent to another line segment. The reasons that you can use next to side congruences are given. You could be given that two line segments are congruent. Definition of midpoint. A midpoint divides a line segment into two congruent line segments. So you can use definition of midpoint that those two halves are congruent. You can use reflexive property to show that sides are congruent. If it's the same side, but it's in two different triangles, then you can use reflexive. You can also use transitive to show that sides are congruent. And of all of our reasons, those are the only ones that you can use to show that sides are congruent. So we're going to do a one-step proof for sides. For this property, you do not need a given statement. We are going to prove that MR is congruent to MR. And the reason that MR, which is in both triangles, is congruent to itself is reflexive. We have successfully shown one of the sides in our two triangles, one pair of sides, are congruent using the reflexive property. Okay, for this proof, we need to have a given statement. So this is going to be a two-step proof. We are given that M is the midpoint of AY. So we have to write that one down. We do not yet have a congruence symbol. So we do not yet have a side. We only have this statement, which doesn't have a congruent sign. So we have not yet shown anything about our sides. What we can prove, because M is the midpoint of AY, we can prove that YM is congruent to MA. We can only show that because we know that M is exactly in between Y and A by the definition of midpoint. So YM is congruent to MA, and so we can write that as our second statement. YM is congruent to MA, and in our diagram, we just successfully showed a side, as long as we have a reason here. The reason that YM is congruent to MA is the definition of midpoint, which says that the midpoint divides our line segment into two congruent line segments. Here's a three-step proof using sides. So we were given, that AM is congruent to HM. AM is congruent to HM. We don't yet have a side because those two sides are in the same triangle. So I'm not going to write an S next to that statement. But we were also given that AM is congruent to MT. So AM is also congruent to MT. That was a given. And now we have a pair of sides because we have AM and MT. So we have a pair of sides. That's how you can use a given statement to show that two pairs of sides in your triangles are congruent. Now I'm looking at my list of statements, and I notice that AM is congruent to HM and AM is also congruent to MT. So I can use transitive, because I have a whole string of congruences, to show that HM is congruent to MT because they're both congruent to AM. The reason for this is transitive, and I was given, I just concluded a side, so now I have two side pairs in these two triangles. All I would need to show congruence would be a third side or another angle. So what I was able to prove from those givens was that HM was congruent to MT, and I was able to do it using the transitive property. These are the only reasons you should have next to a side congruence statement. A given, like we had in this example. Definition of midpoint, like we had in this example. Reflexive property, like we had in this example. Or transitive property, like we had in this example. Please master the congruent statements that you can use for sides for your proofs. Thank you. The next video will be about angle congruences.